Hi, this is Chapter 5 on form tolerances. So far in this class, we've been reviewing how to put stuff on drawings and setting up how to do GD&Ts, and some of the terminology and symbology and stuff like that. So now we're actually going to talk about how do you apply these form tolerances and what they mean. So for the rest of the semester, we'll be talking about new GD&T topics. So our objectives for this lesson are: draw the four symbols for form tolerances. There are four form tolerances we're going to talk about. Number two, complete a feature control frame to specify a form tolerance and to properly apply material condition modifiers on those tolerances. Number three, explain the amount of form control established by limits of size. Number four, apply a straightness tolerance to control surface elements and show the interpretation of the straightness tolerance. Number five, apply straightness tolerances on a feature of size to control the derived medium line and to show the interpretation of the straightness tolerance. Explain and calculate the virtual condition of a regular feature of size that has a form tolerance applied to it. And seven, explain the interaction between size tolerances and form tolerances in regards to Rule 1. Number 8, apply flatness to control a surface and to show an interpretation of a flatness tolerance zone. Number 9, apply a flatness tolerance on a feature of size to control a derived median plane. And 10, circularity. And then finally 11 is cylindricity. So we're going to be talking about all of these different form tolerances. We're going to spend a lot of time particularly on straightness, because straightness sets up a lot of the interpretations. So straightness is kind of like generic, and once we talk about straightness a lot, you'll have a better idea how the other ones go. Okay, so form tolerances. According to rule number 1, a feature must have perfect form at its limits of size. That's the maximum material condition. So therefore, a feature's size tolerance controls the form up to the MMC limit. Now, form tolerances are specified only when form variations must be less than the permitted size of tolerance. Okay, so when you talk about Rule 1 says perfect form you have to have perfect form at maximum material condition. Okay, so if you need to do better than that, that's when you start applying a form tolerance. So form tolerances are specified only when the form variations must be less than what is permitted by the size tolerance. Okay, therefore a form tolerance is needed when other tolerance, size, profile, orientation, or runout do not provide adequate control of the feature. And these can actually minimize part cost if applied correctly. I like to show this slide up here because it talks about all of our 5 different categories of geometric tolerances, and then this breaks it down by what the characteristic is within that category, and then what the symbol is for that characteristic. We like to talk about form tolerances first because we never use a datum reference. It's one of the simpler, if you will, type of tolerances to construct. So we're going to start there. And then as the class progresses, we're going to talk about profile tolerances, orientation tolerances, positional tolerances, and then finally runout tolerances. So we're going to be starting right here in form, and there's never going to be a datum with it. So here are the symbols for our form tolerances. Just a straight line, that's straightness. This is a parallelogram, and that's flatness. A circle is circularity, and the circle with the 2 lines, that's cylindricity. So those are the 4 types of form tolerances that we're going to be studying in this lesson. So what does a feature control frame look like? It looks just like this, where we'll have the geometric characteristic, we'll have a diameter symbol only when applicable, and then we'll have the tolerance here, and form tolerances again have no datum feature references. And then, of course, per rule number 2, RFS is always assumed when it's applicable. Okay, so geometric characteristic, diametral symbol only when it's applicable, RFS assumed when it's applicable, and definitely no datum feature references. Now we can use modifiers with form tolerances. RFS is assumed if no modifier is shown, rule 2. But MMC or LMC can be applicable only when applied to a regular feature of size. Okay, so when we talk about form tolerances, they can be applied to features of size and they can be applied to surfaces. Okay, so in which case, the MMC would only be applicable if we were talking about applying our form tolerance to a feature of size. Okay, free state symbol is used only when another tolerance applies in a restrained condition. Okay, yeah, we'll talk a little bit about that. That's something that's been distinguished in GDT 2018. We talk about a free state, and so what 2018 distinguishes is that there can be a difference, or a tolerance can be applied in a free state, or if you had to apply it in a constrained state. Okay, and we'll talk about what that means. And then statistical symbol when tolerancing value is statistically calculated. Yeah, we're not going to talk too much about that in this course. Okay, so here is a form tolerance applied to a single feature. Okay, so separately controls individual features when applied to multiple coplanar and coaxial features, and then an interrupted features act with one continuous feature symbol. Okay, so in this case we have a form tolerance, it's flatness, and it's being applied to this surface here. If we were doing that on a model, we would show the annotation plane like this, with a leader coming down and a dot on that surface. If we were showing it on an orthographic view of a drawing, we would put an extension line from that surface and then apply the feature control frame directly to that extension line. That's how we would do that. Surfaces and features of size. Form tolerances have different meanings if it's applied to a surface versus if it's applied to a feature of size. All features of size have surfaces, but not every surface is part of a feature of size. Form tolerances are not applicable to irregular features of size, only regular features of size. That's your thicknesses, widths, cylindrical shapes, whether it's a hole or a shaft or cylindrical part. Okay, let's talk about rule number 1 a little bit. So perfect form at MMC is required. So the variation is permitted as feature departs from MMC, and perfect form is not violated. When we talk about perfect form boundaries at MMC, and this has a lot to do with how GD&T works, especially when you're using MMC modifiers. And an MMC modifier would be something that appears in the tolerance block of a feature control frame, and MMB, maximum material boundary modifier, would appear in a datum reference. But what you need to understand about GD&T is that when you're using MMC modifiers, what you're really doing is you're assuring that your parts are going to fit properly, that they'll be able to be assembled. Okay, so rule number 1, you need perfect form at MMC. And then that also states that when you approach the LMC, perfect form is not required. Okay, that's what I'm saying. When the part's at its MMC, that's when you worry about the part getting hung up and not fitting in its next level assembly. So as the part deviates from the MMC, you actually have more leeway in terms of how much tolerance you have on the form of features. I want to end this slide right here, and I'll pick up with slide 16 in the next movie. Thank you.